The next exercise is exercise 12.4. And again, we have a perfectly competitive industry with a large number of potential entrants. Each firm still has an identical cost structure, but now we consider the long run average cost instead of the short run. And the long run average cost is set to be minimized at an output of 20 units. The minimum average cost is $10 per unit, and total market demand is given by the equation 1500 minus 50p. Question A starts easy. What is the industry's long run supply curve? Well, to get at that, the picture is as follows. We're in the long run. So in the long run, firms can freely enter and exit the market, and no firm will be able to make a positive profit because all firms are identical and we're in a perfectly competitive environment. So in the long run, the cost will be at a level where the marginal cost is intersecting with the average cost, and the average cost will be at the minimum level. So in the long run, each firm will produce 20 units, and the cost will be equal to the price of 10. So each firm produces at the minimum efficient scale. And this is a constant cost industry, since the minimum of the average cost in the long run doesn't depend on the output and or the number of firms. So it doesn't matter whether the industry consists of 10 firms or 100 firms. In the long run, the average cost will be minimized at 10. And later on, we will see some examples of an increasing cost industry. So the long run industry supply curve is identical to P is equal to 10. So it's the horizontal flat line. In the long run, the number of firms will always adapt such that each firm will produce 20 units, they will sell at a price of 10, and we have infinitely elastic supply at the price level of 10. So very simple equation, and this completes question A. And then we can move on with question B. So what is the long run equilibrium price? The total industry output Q star, the output of each firm, the number of firms, and the profits of each firm. Now we already know that the output of each firm is equal to 20. We also know that the equilibrium price is equal to 10. And when we plug this into the market demand function, we get that demand at the price of 10 is equal to 1000 units. In the long run, demand equals supply, so also 1000 units need to be supplied. We know that each firm will produce 20 units, so the total number of firms will be 1000 divided by 20. So in the long run equilibrium, we will have 50 firms. And well, just the market demand function looks like this very simple graph. And the profit of each firm, and that's the negative news for the firms in this industry, individual profits in the long run are identical to 0. This completes question B. And now we are ready to do question C. In question C, we focus on the short run, and we are given the short run total cost function associated with each firm long run equilibrium output. So the equilibrium output of 20. The long run equilibrium output is the output where the firm doesn't make a profit. So total revenue must equal total cost. And this cost function is given by this equation over here. And we are asked to compute the short run average cost function and the short run marginal cost function. And at what output level does the short run average cost reach a minimum? So let's do that. I repeat the function over here. And the short run average cost function is identical to the total cost in the short run divided by Q. So we divide each element by Q, and we get to this average cost function, 0.5Q minus 10 plus 200 divided by Q. And this is the fixed cost, and this is the variable cost, so this doesn't depend on Q, this does depend on Q. And we can see that if we produce 0, our cost is equal to 200. If we start to produce, then our average cost of production, they start to decline. Now, the marginal cost is the derivative of the cost function with respect to Q. So doing that, we get Q minus 10. And then we are asked to compute the minimum of this function over here. So for which Q is the average short run cost minimum. And to find a minimum, you usually take the derivative of a function, set it equal to 0. That's what we do here. So we differentiate the average cost function with respect to Q. And we get 0.5 minus 200 divided by Q squared. We set it equal to 0 in order to find the minimum. And the minimum is at 20. So what you can see, and you can do it graphically, so this is the average variable cost. So this is the total variable cost. If we divide this part of the cost function by Q, we get the average variable cost. And what it shows you is that at a quantity of 20, where we started out with in question A, at the quantity of 20, the total revenues of the firm are price is 10, quantity is 20, is 200, and the total cost is identical to 200 as well. So the firm is just able to recoup the fixed cost of 200, and the average variable cost at this quantity of 20 are identical to 0. And the marginal cost is equal to 10, which it should be, because it should be equal to the market price. Okay, so this completes question C. And now we continue with question D. Calculate the short-run supply function for each firm in the industry short-run supply function. So to start with the firm level supply function, we should check if the firm produces how many units it will supply, and then we should also focus at the shutdown decision. Will the firm find it beneficial to supply at all? So the output decision, if active, how many units, is determined by setting marginal revenue equal to marginal cost. The firm is a price taker, so marginal revenue is equal to the market price. Marginal cost is from the previous slide, Q minus 10. So the supply function of the firm, quantity as a function of price, is equal to P plus 10. But will the firm produce at all? Is for this level, does the firm recoup some of its fixed cost? Now, it only recoups part of all of the fixed cost if the price that it receives exceeds or is at least identical to the average variable cost. The average variable cost is equal to 0.5Q minus 10. Look at the graph from the previous slide. Marginal cost is equal to Q minus 10. And marginal cost or price should exceed average variable cost. This holds again for all values of Q, because we can see that for any Q, Q minus 10 is higher than 0.5Q minus 10, because the 10s minus 10s, they cancel out, so Q should be at least equal to 0.5Q, and this holds by definition. So the firm will produce and it will supply P plus 10 units. So this is the individual supply function, and the industry supply function, well, in total we have 50 firms, so we multiply the individual supply just by 50 and we get the industry supply function in the short run. So in the short run, the number of firms cannot adjust. Now suppose that there's a shock to market demand. Market demand shifts upward to 2000 minus 50p, Using a new demand curve, answer part B for the very short run, when firms cannot change their outputs. So in the short run, we have that there's no entry and exit. In the very short run, in addition, firms can also not adjust their output. So the firms that are active in the industry will continue to produce 20 units. So the demand function is 2000 minus 50p in the new situation. Supply is equal to 1000 because the firms cannot adjust. We have 50 firms producing a quantity of 20 each. So in the very short run, the equilibrium price will adjust upward, reach a new level of 20, and the total quantity supplied by each firm will remain 20. So for firms, this is great in the very short run because now the market price of 20 exceeds their average cost. So on each unit that they sell, they make a profit of 10. In total, they sell 20 units, so the total profits are equal to 200. And this completes question E. And then we can continue with question F. In the short run, so this is not a very short run, it's also not a long run. It means that the firms that are active in the industry, they can adjust their output, but entry and exit is not possible. So in the short run, use the industry short run supply function to recalculate the answers to B. Now we do this as follows. We have the new market demand. We have the supply function 50p plus 500. So that's the same purple one as over here. We equate supply and demand because now firms are no longer tied to supplying an output of 20 units. If we do that, we reach a new equilibrium price of 15. So the big difference is that in the very short run, supply needs to be 1000. In the short run, it will adjust, each firm will adjust its output dependent on the market price. The equilibrium market price is 15. Total quantity produced by the 50 firms that are active in the industry is 1250, and each individual firm will not supply 20 units, but now supply 25 units because the price has increased, making it more attractive to increase supply. At the price of 15 and a quantity of 25, the average cost of the firm is equal to 10.5. So the average cost also increased a little bit compared to the previous, but on each unit they make a margin of 4.5, 15 minus 10.5. They sell 25 units, so also in the short run firms are able to make a profit, and this profit is equal to 112.50. Now, to complete the exercise, we move to the long run. So in the long run, firms that are active can adjust their output, but also new firms can enter the industry or existing firms can exit. And we saw in the previous question that the firms make a profit in the industry, so that will attract entry. And in the long run, entry will continue up till the point where none of the active firms will make a profit. So in the long run equilibrium, prices will again go to 10, because we already had in question A that the long run supply is a horizontal line. It's perfectly elastic. So long run equilibrium price is equal to 10. We plug in this value of 10 into the new demand function. So the new equilibrium quantity is 1500. Each firm, since none of the firms will make a profit, and the market price again is 10, so each firm in the long run will produce 20 units. So, and with 20 units per firm and 1500 units in total, it means that we have an entry by another 25 firms, bringing the total number of firms up to 75. And equilibrium profits are back to 0.